kitchen designers, code officials, builders, engineers, architects and homeowners have known for a long time that a large range hood is the main culprit in home depressurization and all the nasty stuff that goes with it, such as backdrafting open fireplaces and atmospheric water heaters, air infiltration under doors and around windows and cracks causing drafts to occupants, to say nothing of radon and soil gas intrusion. The Building Performance Institute and Residential Energy Services Network develop standards for depressurization limits in residential appliances. As you can see, it doesn't take much to cause depressurizations in today's tight homes. -5 pascals for an atmospheric vented water heater equates to 0.02 inches of water column. The 2009 and 2012 versions of the International Residential Code recognize the need for makeup air for kitchen exhaust fans over 400 CFM and the requirement to supply air at the same rate as the exhaust air, with a closure to stop air infiltration or treated air leaking out. The 2015 version of the International Residential Code maintained the same balanced airflow, but now it could be supplied naturally, which is basically a hole in the wall, mechanically, a fan. However, there must be not less than one automatic damper, either electric or gravity. This not less than one was inserted because many homes have one small damper installed and they don't work. Well, go figure. Sucking air through a hole needs pressure differential, in this case depressurization, just what the code was designed to stop. So let's look at this damper or natural makeup air option. Natural really means a hole in the wall, just like an open window or door. This is a fancy way of saying that air is sucked in by depressurization from the exhaust fan. Oops! Depressurization, just what the code was written to prevent. However, the size of the hole limits the amount of air comes in. The smaller the hole, the less air. Using this equation, we can draw up a table for airflow through various holes. Knowing this, let's look at a leading proponent of engineered systems, Brown. Let's look at this home in New Jersey. We interlock the makeup air with the air handler to help the air in, have a short run of duct, throw in the exhaust for bath fans and dryer exhaust. Now notice that the design exhaust rate is only 940 CFM. No blower door test, and use a short length of flexible insulated duct. So what do we get? Lots of holes in the home. And don't forget, you could end up with 7 duct runs, 7 lots of cable to operate dampers if you choose electric dampers. That's a lot of installation. Do you really want your home to look like this? Here they tell you that with all those holes, the makeup air is still insufficient for the hood exhaust, and gives some options, which includes downsizing the hood fan. And don't forget, if the air temperature into the return air of the furnace is below the manufacturer's recommendations, normally around 53 degrees Fahrenheit, the warranty on the furnace may be void. In fact, an independent white paper on residential makeup air points out the pitfalls and serious limitations of natural makeup air. This paper can be viewed or downloaded from the Fantech website below. So, wouldn't you want a system that actually works? The Fantech makeup air system and all of its component parts, EC fan, filter, electric damper, supply hood, clamps, control, silencer, together with the optional heater, are designed to work seamlessly with any manufacturer's hood exhaust fan and deliver the balanced airflow required by code. Once the system is commissioned, it works like this. As the exhaust fan is turned on, a current transducer sensor on the exhaust fan's power wiring activates the make-up air control. The make-up air control then opens a 24-volt damper and commands the make-up air fan to deliver air to the home. The make-up air fan's speed is automatically varied as necessary via a 0 to 10 volt DC signal to compensate the exhaust airflow rate within its range from minimum to full speed operation and any rate in between. If fitted, the optional heater will be enabled to automatically add variable heat to the air to the pre-programmed discharge temperature set point. Sufficiently tempered air can now be delivered directly to the space where the exhaust fan is pulling from. Introduction of make-up air into the central HVAC system raises issues with furnace warranty, temperature control, and the central system's ability to handle a high percentage of outdoor air. For these and other reasons, it is strongly recommended that the make-up air system not be integrated with the central HVAC system. When a make-up air system includes tempering, a filter is required per ASHRAE 62.2. However, it's good practice regardless. A filter helps to remove outdoor dust, pollen, etc. and stop it from entering the home. Selecting your Fantech make-up air system is a very simple two-step process. These three easy-to-size systems with airflows up to 2000 CFM at 0.5 will cover the vast majority of residential range hood exhaust systems. To go along with this, there are three heater combinations for various airflows and delivered air temperatures. If unsure of your requirement, from the map, select the heater based on your geographical location and the average outdoor temperature. Then simply select the heater based on the exhaust fan's maximum airflow, the temperature zone you're in, and the temperature rise required. The selected heater comes with all components to fit into your Fantech make-up air system. Your Fantech make-up air system will provide trouble-free, balanced airflow for your kitchen range hood for many years to come. No more worries about backdraft in the fireplace or gas-fired appliances, drafts, infiltration, or having to open a window or door to get the range hood fan to work properly. This concludes part 1 of the Fantech Make-up Air series. In part 2, we show a typical installation, and in part 3, wiring and commissioning the system. Fantech Make-up Air System. Simply better.